So, a lot to get through. Let's start straight away. So, as was remarked, this is now nearly 30 years old. And to do climate-based light modeling, we want description of the sun, description of the sky. And of course, we get this from the weather files, and we generate sun and sky conditions from those values, hourly typically, and we predict our internal illuminance in the space. Fine. We take the standardized weather files because, of course, they've been used already for decades in dynamic thermal modeling, so they must be good. The simplest single measure of a file, weather file, is just to give an annual total of the global horizontal, beam direct, diffuse horizontal. We're not interested in this, really. It's the sun and the sky separately. So these are the annual totals for Gatwick. And it's taken from the Energy Plus weather file. Is it Gatwick weather? Well, who knows? And actually, when it's one file, it doesn't really matter because everybody's using the same yardstick, as it were, to generate their conditions. And then lots of more weather files start to appear from the Climate One website. And they've taken from a full mix of years, then a limited range of years. Of course, they're unique months put together, so these are synthetic years that never happen. And this is a bit of a shocker, really. Really? That much beam direct normal variation in your weather files? Yeah, those rulers match those numbers. And if you're really in a position where you had to defend results from a CBDM simulation, and how can you justify the choosing of one weather file over another? Okay, so let's find a way of picking the right weather file, because one of them must be right. Ground truth data. Yeah, but who's got ground truth data for everywhere where we might want to simulate? Well, the ground truth data may actually be, we may have a source of it from up there. Okay, let's have a look at this. The CAMS data, they produce hourly and 15-minute data of irradiation, ground level irradiation. And this has been from 2005 onwards. Well, continuous years. It began in 2004. And the full disk is what the satellite sees, but the region of reliable data is within that plus or minus 60 either way, latitude and longitude. And it's about 36 million meters above the equator. Okay, but let's just check the ground truth up there with some real ground here. I had some data from a number of National Trust projects, Ickworth House, that one, and Boris Edmonds, another one, Ham House, whatever. But I had data of 610 days at 1 minute in the grounds where they can see pretty much unobstructed. And this is for what we were doing inside the spaces, really predicting daylight fall onto paintings and fabrics and whatever. But this data never got used until now. We're interested in just the global horizontal, the DHI that's derived here. It's a less reliable number. But we've got a global horizontal, so we can check. So we derive the global horizontal illuminance from the beam normal irradiance and the diffuse horizontal irradiance from the CAMS data. And we look at the 15-minute data, and this minute data on the ground, we average that to 15 minutes, whatever, apply the luminous efficacy factors in that derivation. And there we have 1 day. On the ground, the BF5, there's the CAMS in blue, a nice sunny day in July. And you see that, and you have to kind of pinch yourself that one of those is 1 meter above the ground, and the other one is 36 million meters above the ground. These are again, the GHI, the daily totals in kilolux hours. Another day, this was even more stunning, really, because we've got sub-hourly variation. Think of where that satellite is and the parallax error, the relatively high latitude values for these locations, and you're getting reasonable synchronicity there. between the two, and again, the daily totals shaded green, so it's within 5%. Another one, and another one. Okay, so there were 610 days, the full days there, again, remarkable agreement on full days. 60-minute, again, quite astonishing, and even at the 15-minute, more scatter but no increase in bias. Absolutely remarkable. In fact, the bias decreased on the sunnier and sunnier days. So there was enough in that validation to show that, yes, we can take the CAMS data, as reliable representations of actual meteorological years. So why don't we compare 10 years of Gatwick from the satellite with the 4 Gatwick weather files. And we'll look at this. So this work was done in 23. And so the full years, 10 years, were from 2013 to 22. And also look at the 60-minute and the 15-minute data. And we use something very simple, frequency distributions. Can't really get simpler than that. So look at the annual distributions for all those years and for all those 4 TMYs. So we've got the beam normal and 5,000 lux bins, put it in there, distribution, simple. Do the same for diffuse horizontal, fine. And we look at 2 sorts of distributions, just the number distribution, how many fall into those bins, and then actually the kilolux hours, because of course 1 hour difference here makes much more in the total of kilolux hours than here. So this kilolux hours distribution now it's like the total amount of light energy, if we will, in there. So we look at those 2 ways of showing distributions. Oh, I'm blocking myself there. Right, so, and we want to look at these on top of each other. If we use the staircase, it'll just look a mess. So we look at frequency polygons, where we just draw these polygons from the center points at the tops. And then we can look at a lot of them on top of each other. The CAMs, the 15 minutes, the 10 years, we give them those colors. It's a continuous scale for there. Then some distinct colors for the 4 TMYs. And we plot the frequency polygons on top of each other. And this was the first surprising thing, that I was expecting a lot of inter-year variability in the CAMs. And instead we got this thread here. And the TMYs all kind of sitting out, look like they're really not part of that thread at all. And for diffuse horizontal illuminance now, we've got, again, something kind of similar there. And when we look at the magnitude now in kilolux hours, those differences get even starker. So the thread's pretty tight there. Here's where the difference is in the annual totals, but it's all at this end. And again, the 4 TMYs, the 4 standardized files that are supposed to be typical, don't really fit into that envelope of distributions from the CAMs. Again, similar with the DHI. So, how to quantify what is kind of evident to the eye? The eye is very good at seeing these things. So how do we do it here? And the only way to go is really to compare one with another and do it for all possible pairs. And do something very simple and just count the total of that difference, whether it's positive or negative, doesn't matter. We sum the absolute differences, and we end up with the sum of the absolute difference for both number and magnitude. And we ignore the first bin, because this is the dawn-dusk bin anyway. Pairwise. Now, pairwise, because we have no idea what the population mean is at all. Yeah. And we use a dissimilarity matrix. And the way this works, if we want to compare, say, that TMYX with this CAMS, then we color in that point where they cross over with the size of that difference. Yep. And we've got The characteristics of this matrix for a start is mirrored along here. So you've got the same data this side of the mirror as that side. And we've got number of distinct regions. We've got this one where you're just comparing CAMs with CAMs. Here, TMY with TMY. Sorry, TMY with CAMs. And mirrored up there. TMY with TMY. And put that difference into a color. Blues and reds, greater similarity. Oranges, yellows, greater dissimilarity. And if we look there, it's like, well, wow, it looks, here we've got similarity. And there, the TMYs are not really similar with any of those 10 years of CAMS data. And what's more, they're not really similar with each other. And then we'll look also at the diffuse horizontal, and it's, wow, yeah. So okay, and then we look at the magnitude difference. It leaps out even more. These TMY distributions don't agree with CAMs. They don't agree with each other. So I better look somewhere else. Stockholm, pretty similar. Rome, somewhere a bit sunnier now. So 3 clusters evident. You can see it. You've seen it. Hardly need to spell it out in bullet points. None of those were expected. So the aim of this exercise began to pick out the one TMY. Climate change. It's being measured, and the distribution in change is quite varied, and in fact it's in the less sunny places that we seem to be getting more sun. So now we started off with 2005 with the CAMS data. So this is 10 years now of max, min, and means, mean and median and mins for the 2005 to 2014 for beam normal. This is for Gatwick again. And this is how those change from 2005 to 14 to 2015 to 24, the most recent. No one else has seen this one before. This is its first outing here. Those ticks are the 4 TMYs. But we're seeing how this envelope has got larger. And there is for DHY as well. Again, with beam normal going up, you're going to get some DHI drop there. So where does this go? Reconsideration of the basis of solar radiation TMYs. That's already happened, and it's already fed into the creation of the new SIBC lot. They've certainly focused more on Copernicus, even though other things are still pretty traditional. Daylight standards, well, there is discussion about actually having tables based on CAMS data, possibly 10 years. In situ validation, we now have a fantastic daylight resource there. Personal light exposure field studies, we just need the lat and long and the time of those studies and get the baseline conditions outside. And the really radical suggestions to think about doing a recent meteorological decade of evaluations rather than just a single eye, and in which would allow you to automatically sort of incorporate measured climate change effects. All of this is discussed in quite a long paper, which does the validation and the weather file stuff. And is it going to be a gruesome read, a long paper like that? Well, the opening comments from the 2 reviewers suggest not, actually. Yeah, hugely tickled with those. Thank you very much.
Thank you very much.